It has already fired 4 X-class flares and 13 M-class flares, and it has not even turned to face Earth yet. Every single explosion so far has been aimed at empty space. That changes in 7 days. The most energetically significant sunspot group of the entire current solar cycle is rotating around the far side of the sun right now, charging up, and on approximately May 22nd, it crosses into direct Earth-facing position for the first time. Solar physicists are not calling this a routine active region. They are calling it the most dangerous solar region of 2026. And the last sunspot that matched this description did something most people still do not fully understand happened. By the end of this video, you are going to understand exactly what makes this sunspot different from every other active region that has come and gone. This solar cycle, why the far side activity record it has already set, is the detail that matters most, and what the 7-day countdown actually means in practical terms. We are going to go through the full comparison with AR3664, the sunspot from May 2024 that produced the strongest geomagnetic storm of solar cycle 25, a G5 extreme event that put aurora over Florida, knocked out GPS across multiple regions, and stressed power grids across 3 continents. And then we are going to get to the part that nobody in mainstream space weather coverage is laying out clearly, because this incoming region has already exceeded AR3664's prefacing activity. What AR3664 did after it reached Earth-facing position is the data point you need to understand right now. Stay with me through this entire video, because around the 7-minute mark, I'm going to show you something in the alignment data for May 31st that adds a variable to this situation that has not appeared in a single news headline about this event. Let's start with what X-class and M-class flares actually are, because those classifications carry specific meaning, and the numbers attached to this sunspot are not routine. Solar flares are classified by their peak X-ray output. The scale runs from A through B, C, M, and X, each step representing a 10-fold increase in energy. An M-class flare is powerful. It is capable of causing brief radio blackouts on the sunlit side of Earth and elevated radiation in polar regions. A single M-class flare from an Earth-facing sunspot is enough to trigger alerts from NOAA's Space Weather Prediction Center and put satellite operators on watch. An X-class flare is an order of magnitude beyond that. X-class flares can cause extended high-frequency radio blackouts across entire hemispheres, radiation storms that force astronauts to shelter, and if accompanied by a significant coronal mass ejection aimed at Earth, geomagnetic storms capable of damaging satellites and overloading power grid infrastructure. This sunspot has produced 4 X-class flares and 13 M-class flares before it has even rotated to face Earth. Every one of those explosions was launched into the far side of the solar system, away from every planet, away from every satellite, away from Earth entirely. The explosions were real. The energy was real. Earth just was not in the way. In 7 days, Earth is in the way. That is the sentence the data is building toward. The sunspot does not cool down when it rotates. It does not exhaust itself from the far side activity. Active regions at this scale of magnetic complexity do not simply stop. They evolve. And in some cases, they intensify as they approach the solar western limb and then cross into Earth-facing geometry. Here is the detail that separates this from a standard space weather story. The level of far-side activity this region has produced before even entering our field of view is, by the documented record, extraordinarily rare. Solar physicists tracking it through helioseismic imaging, essentially an acoustic map of activity on the side of the sun we cannot see directly, have been watching this region build for days. And what the data shows is a sunspot group with a level of prefacing energy output that has only been matched or exceeded a small number of times across the entire modern space weather observation record. We have a comparison case for what happens when a region like this rotates into Earth-facing position. It happened 13 months ago, and the consequences of that event are still being studied. Stay with me past the 4-minute mark, because the AR36664 comparison is the part that closes the gap between abstract solar physics and what actually happened on the ground, on satellites, on power grids, to GPS signals that farmers, pilots, and surgeons depend on. May 2024, AR36664. That is the reference point every solar physicist working on this incoming region is using internally. AR36604 was the most powerful active sunspot group of solar cycle 25 up to that point. When it rotated into Earth-facing position, it immediately began producing major flares directed straight at Earth. The result was a G5 geomagnetic storm, the highest rating on NOAA's scale. The first G5 event since the Halloween storms of 2003. Aurora was visible as far south as Florida, Texas, and the Caribbean in the northern hemisphere. In the southern hemisphere, it reached latitudes that had not seen visible aurora in living memory for most residents. That part made the news. The photographs were extraordinary, and they spread across every platform. But the parts that did not make the viral posts are the parts that matter for understanding what a comparable or larger event means in 2026. GPS accuracy across multiple agricultural regions degraded significantly during the storm peak. Precision farming equipment that guides planting and harvesting to centimeter accuracy was throwing errors measured in meters. Airlines operating polar routes diverted. The radiation environment along high-latitude flight paths exceeded safe thresholds for crew and passenger exposure. HF radio, the backup communication system that aviation depends on when satellite links fail, blacked out across the sunlit hemisphere for extended periods during the strongest flare activity. Power grid operators in Canada and Scandinavia recorded geomagnetically induced currents in transmission infrastructure. Some protective relays tripped automatically. The systems handled it. But the margins were not comfortable, and the post-event analysis from multiple grid operators noted that a storm of similar intensity with slightly different magnetic field orientation at impact could have pushed several high-latitude substations into dangerous territory. Now, here is the critical comparison point. AR3664's most destructive activity, the flares that produced the G5 storm conditions, came after it reached Earth-facing position. Its pre-facing activity, the flares it produced while still on the far side and at the solar limb, was significant but measurably lower than what the incoming 2026 region has already produced before crossing into view. The incoming region has already exceeded AR3664's pre-facing output. That is not a projection. That is a measurement. The helioseismic data and the far-side flare activity record document it. What this means for what comes after May 22nd is the question that every Space Weather Center with monitoring capability is now working on in real time. And there is still one more variable in this situation that has not been widely reported. Here's the moment I promised at the start of this video, the alignment data for May 31st. Because the sunspot does not simply rotate into Earth-facing position and stop there. It continues across the solar disk over the following days, and the geometry of where it sits relative to Earth changes as it moves. The most precise Earth-center alignment, meaning the point at which the sunspot is directly facing Earth at the center of the solar disk, is projected around May 31st. That is the geometry where a major flare carries the highest probability of launching a coronal mass ejection directly along the Earth-Sun line, not at an angle, not as a glancing blow, straight at Earth. May 31st is a full moon. That is the variable that has not appeared in a single news article covering this event. A full moon means the moon is on the opposite side of Earth from the sun, in precise alignment with the Earth-Sun line, the same line that a directly aimed CME would travel. The research on lunar position and geomagnetic storm intensity is not settled science, but it is active science. There are published papers examining whether the moon's position during geomagnetic events influences the distribution of induced currents in Earth's ionosphere and crust. The mechanism proposed involves tidal effects on the ionospheric plasma density. Whether or not the full moon adds measurable intensity to any storm produced by this sunspot, the timing is notable for a different reason. Full moon conditions create tidal maxima in ocean and crustal systems. A G4 or G5 geomagnetic storm arriving simultaneously with spring tide conditions on May 31st produces a compounding stress environment across multiple Earth systems that does not appear during ordinary storm events. Here is the by-the-way moment for everyone who has stayed this far. In May 2024, during the AR3664 G5 event, there were documented reports from multiple countries of anomalous behavior in migratory bird populations, disrupted whale navigation patterns, and elevated stress indicators in captive animals with known magnetic sensitivity. These are not fringe claims. They are documented behavioral observations from wildlife researchers correlating with the geomagnetic storm timeline. The magnetosphere that protects Earth's surface also provides the navigational reference that hundreds of species depend on for migration, feeding, and orientation. A G5 event does not just stress human infrastructure. It temporarily rewrites the magnetic map that a significant portion of Earth's animal population uses to navigate. That is not a footnote. That is a consequence that almost no space weather coverage ever includes. Let's close every loop opened at the beginning of this video. The far side activity record, 4 X-class flares, 13 M-class flares before Earth-facing position, is documented and confirmed. It exceeds AR36664's pre-facing output. That comparison is the foundation of why solar physicists are treating this region differently from a routine active sunspot. The 7-day countdown is real. May 22nd is the projected crossing point into Earth-facing geometry. From that date, any major flare has the potential to launch a CME aimed at Earth. The window of elevated risk is not a single day. It runs from first rotation through peak Earth-center alignment, which extends across approximately 10 days of maximum exposure. The May 31st full moon alignment is a convergence point, not a guarantee of catastrophe. What it represents is a date on which multiple variables peak simultaneously. Maximum Earth-facing geometry, potential flare activity from the most energetic region of the solar cycle, and tidal and ionospheric conditions that compound the effects of any geomagnetic disturbance that arrives. What does preparation actually look like for an event of this potential scale? It looks like what grid operators in Canada did in 1989 after the Quebec blackout. They installed geomagnetically induced current monitoring on major transmission lines and pre-authorized protective disconnection procedures that do not require real-time human approval chains. Some grids have this, many do not. It looks like what airline dispatch centers did during AR3664, pre-positioning alternative routing plans for polar routes so that when the HF radio blackout alert came in, the diversion decisions were already mapped. Reaction time in that scenario went from hours to minutes because the scenario had already been gamed out. It looks like what satellite operators do when a major active region is confirmed Earth-facing. They schedule software updates and non-critical maneuvers before the storm window, they put sensitive instruments into safe mode, and they pre-position backup communication links for the period when primary channels may be degraded or lost. Most of that preparation is invisible to the public. It happens in operation centers and grid control rooms and satellite management facilities that most people will never see. But it is the difference between a G5 storm that history records as a spectacular light show and one that history records as the event that cost a hemisphere its power grid for an extended period. The infrastructure answer to space weather is not exotic. It is not theoretical. It exists and it works when it has been implemented. The gap is coverage. How much of the critical infrastructure has been hardened versus how much is still operating on assumptions built before the modern understanding of extreme space weather consequences was fully developed? Here is where everything lands. The most energetically significant sunspot group of solar cycle 25 is currently on the far side of the sun. It has already produced more pre-facing flare activity than AR3664, the region responsible for the strongest geomagnetic storm of the current solar cycle, a G5 event that disrupted GPS, grounded polar flights, and stressed grid infrastructure across 3 continents. In 7 days, it rotates into direct Earth-facing position for the first time. Its peak Earth-center alignment falls around May 31st, coinciding with a full moon, during what solar physicists are describing as the most consequential monitoring period for any active region in 2026. The activity it produces from that position is not yet determined. The physics will resolve as the geometry changes. What is already determined is the prefacing record. What is already determined is the comparison case. What is already determined is that the last region with comparable energy output changed the space weather record books and produced consequences visible from Florida to New Zealand. This region has already cleared the bar AR3664 set before it even entered the picture. NOAA's Space Weather Prediction Center will be issuing updates as the rotation progresses. The first Earth-directed flares from this region, if they come, will generate alerts that flow to grid operators, satellite controllers, and aviation authorities within minutes of detection. Whether those alerts arrive in a 15-minute window or a 48-hour window depends entirely on whether the ejection is a flare alone or flare with a CME. If this video gave you a clearer picture of what the next 10 days actually mean, not just as a science story, but as a systems event with real infrastructure consequences, share it with someone who should be paying attention. The people who need to understand this are not only the ones already following space weather channels. They are the ones who do not yet know a countdown has started. Subscribe and turn on notifications. When this sunspot crosses into Earth-facing position and the first major flare alert goes out, you want to already understand what you're looking at. The sun does not wait for people to catch up. The 7-day window is already running.